Hello folks, this video is the second one from our small series on implementing microsegmentation on Cisco NXOS VXLAN L2VPN EVPN fabrics, leveraging VXLAN Group Policy Option or VXLAN GPO. In the previous video, we have explored the main pillars of the solution and we checked the theory from the RFCs. Now we are going to head into the prerequisites as well as the different configuration steps in order to enable microsegmentation in a working VXLAN L2VPN EVPN fabric. Before we start, I would like to make a small disclaimer. During this video, I will be switching a lot between different tabs. The tab where I have my PowerPoint for the explanations and the context and so on. The tab where I have my secure CRT for sharing the lab environment and doing together the commands and the testings and so on. And I have also one screen with a text editor where I listed the different tests that I would like to make just so that I hopefully ensure that I'm not forgetting any relevant test that I really want to record. Why am I saying all this? It's because it's the first time for me where I will be switching between so many different tabs while recording. I hope that the video won't get too messy because of that. I will do my best, but apologies if it's a bit hard to follow because of the, the organization mess. So with that said, let's go to the presentation. So as I was mentioning, the main goal of this recording will be to do the configuration into a lab environment. And speaking about the lab, this is what we will be using. Let me just remove my face so that I can show the whole screen. Okay, what do we have? So we have a small fabric that consists into one spine and two leaves. I have already done the configuration of the fabric. It is actually a straightforward configuration where I did the underlay using OSPF and PIM for the replication. I mean, just small details we don't really care about for our purpose, but just to show you where we are starting from. And I configured the overlay with just one VRF and just one SVI inside that VRF. So we have the VRF blue VRF that is already deployed on the two leaves, meaning leaf 1 and leaf 2. And the two leaves as well have the pervasive gateway for the SVI for VLAN 10. And I have also propagated that VLAN on the interfaces that I'm showing on the screen. So it is the interface 1/4 for leaf 1 and the interface 1/3 for leaf 2, meaning this port is a trunk port and it has allowed the VLAN 10 inside, here and here. Then we will be doing some tests back and forth between host 1 and host 2. So the host 1 IP address into VLAN 10 is in .10.1. For the host 2, it is .10.2. And the MAC address, just to make them easily recognizable, I hard-coded them saying that for the host 1, it is 10 for VLAN 10 and 01 for host 1. And for host 2, here we have 10 for VLAN 10 and the 2 for host 2. Now, obviously, we can freely ping and initiate various traffic between host 1 and host 2. I will also show very quickly a screen where all the configuration is displayed, again, just to show you where we are starting from, but it is really the most classical configuration for a working VXLAN L2VPN EVPN fabric, absolutely nothing fancy. Now let's check out what is the final goal that we want to reach. So we want to create two security groups, one security group that I will be naming clients, and we will assign to it the tag 100, one security group named server, and we will assign to it the tag 200. Then we will be matching the host 1 to put it in clients, matching the host 2 to put it in servers. Apologies, the servers should be in capital letters, but no, then never mind. You got it. And by the way, I will be rematching just the exact IP address of host 1 and host 2 to put them into those security groups. If you remember from the previous presentation where we were speaking about the theory and the pillars, etc., we saw that we can actually match on different parameters to put the end hosts as well as the networks into security groups. For this first video related to testing, I really want to make the most straightforward configuration and just match what just the host that I have here. I don't want to create wider masks to match my additional networks or additional hosts that would be added into the VRF. I would like to do this, but in the next video. For the moment, I really want to make the easier configuration, even if it's not optimal, even if it's not what we would deploy into a production environment. Again, I'm just matching on those specific addresses. So coming back to the slide, we will be building some security policies or contracts between our two hosts, host 1 and host 2. So the goal is to permit ICMP between clients and servers, and to permit SSH from client to servers, meaning any other kind of traffic should be denied. So at the end of the configuration, what I want to have is that host 1 can ping host 2 can ping host 1 can SSH to host 2, and that's it. So to illustrate it, I've already prepared also a slide with different traffic generations. It's quite straightforward actually. It's just a ping, a telnet, and an SSH, so that we show what was working before, what is still working after, and what is getting dropped after our configuration. Okay, so I guess that is it for the presentation of our lab environment. I just want to make a disclaimer regarding the lab. It's actually that for the host parts, I don't have two separate hosts to have host 1 and host 2. I'm using just one Nexus 9K to simulate my two hosts. So how am I doing this? I mean, it's pretty straightforward, but I want to highlight it so that you are not surprised when we go to the lab environments to see just one tab named hosts and not two different tabs with host 1 and host 2. So again, this is a Nexus 9K. I configured in it two different VRFs. The first VRF is named Blue Leaf 1 VLAN 10, and the second one is Blue Leaf 2 VLAN 10. And then here I am configuring an interface with sub-interfaces, with encapsulation.1q in 10 here and as well there, so that I ensure that to communicate from this leg to this leg, I go through the fabric. So this is why we have these two VRFs. Otherwise, the host would, the traffic would not go out from the host, right? Okay, so that's it. We have seen the logical configurations. We have seen the physical cabling. So now I'm just going to share the configuration that has already been pushed on the fabric, which is this one. So first we have the interface that is configured for the VRF. So it has a VRF member, Blue VRF. Again, classical configuration. We assign to that VLAN the VN segment for the L2VPN. Then we configure the VRF context. We call the L2VPN. We have the route distinguisher set to auto. For address family IPv4, we have the export and import set to auto as well. Then we configure the SVI for VLAN 10, which is member of the Blue VRF, obviously. We have the IP address that I was mentioning previously. So this is the pervasive gateway. It is in .254. I have a tag 12345 that will be matched inside the router BGP in order to redistribute anything directly connected. So sorry, I'm jumping to the other part, but just to say that this route map is actually simply matching that tag, which is being set into this SVI. So we ensure that the subnet is getting redistributed into BGP. We enable this SVI as a pervasive gateway. We unshet it. Then we define our VLAN with its L2VPN. We configure the EVPN part for setting up the MAC VRF, and the configuration for router BGP. Then the configuration for the VTEP, meaning the interface NVE1. Here we call the two VNIs for which we will be working, meaning the L2VPN for our VRF and the L2VPN, to which we attach multicast group for the transport of the BUM across the fabric. And then finally, we propagate the VLAN 10 on the switched interface that is connecting our leaf toward our host device. So this is really it for the configuration that we have. And let's actually check that it is indeed properly working into our fabric. So first challenge to switch between the tabs. Okay, so here we are. So here I am on my leaf one. Let's go rather on spine one. So we check that we have our OSPF neighbors that are up and running. So we have the two neighbors, which are leaf 1 and leaf 2. And for the BGP peerings, we have the 2 peerings that are up and running. Then if we come back to the deck, just to pick the test that I want to run. So this is what is currently working. I mean, any traffic at the moment is allowed between host 1 and host 2 because we have absolutely nothing filtering anything inside inside our environment. So let me see. Oh yeah, indeed, I cannot copy paste from here. I should have thought of it before. So okay, and then it will not help me to have the commands on the PowerPoint. Then let me type them. Let's go to the host and do a ping .2 from the source interface. So here I am pinging the .2 from 4.10, which is the interface connected to LIF1. We see that the ping is working. Now let me do an SSH towards this address from the source interface. So we see that the SSH is working as well. So I have simulated an SSH from host 1 to host 2. Then let me do a telnet, same to host 2, and then VRF. Actually, on my host, I have more than those VRFs, but we don't really care. I just need that one. And we see that the telnet is working. So again, I have telnetted the host 2, which is in .2, starting from the host 1, which is represented by the source interface that is member of the LIF1-VLAN 10. And if we go to the leaves and we check some tables just to verify that all the learning is there. I mean, all the learning is necessarily there since we are able to ping and telnet and SSH, but you know, just to see the show commands. So here we have the verification of the blue VRF for the IP routing. We see that we have the .1 that has been learned into HMM since I am on LIF1, and we have learned the .2 through BGP, and we are using VXLAN to reach it. Then let's check out the L2 routes. Let's check first the MAC-VRF for, let's check out the MAC address into the MAC-VRF. So we see that we have the local MAC address, the MAC address that has been learned locally, which is the one of host 1 and the other one remotely. And finally, the MAC IP. And we have the two, so one in HMM and the other one learned from BGP. Good, so let's go back into our PowerPoint and see what is our to-do list starting from now. So the first thing that we will be needing on LIF1 as well on LIF2 in order to enable the feature is actually reformatting the SSD. It is a requirement in order to be able to enable the feature and the templates that we will be needing. Once we have reformatted the SSD, we will be able to configure the system routing template security groups. It is actually a template that will do some carving to assign additional resources so that we are able to code the assignment of the tags as well as the security group ACLs. Then we will enable the security group feature. We configure the security groups, meaning client and server in our use case. Then the security class maps, policy map, and applying the policy map, which is done through a configuration inside the context VRF. This is a very high-level view. We will be spending much more time seeing the details of it into the next slides and the configuration that we will be doing together. But I wanted just to show, a global picture of what will be occupying us into the next, I don't know how long the video will be, probably 1 hour. I just want to make a final note on this slide, which is regarding the order of operation between these two. Actually, each one of these two, meaning reformatting the SSD as well as configuring the routing templates, requires a reload. I have put this order of operation to say that configuring the system routing template require reformatting the SSD. But the thing is that even before we reformat the SSD, we are still able to go into config mode and apply the command to say system routing template security groups. When we do this, and we will see it when we do it into the lab, the device will tell us, okay, I have taken your requirements to configure this template, but to enable it, you need to reload, and you need to ensure that we have reformatted the SSD. But it will not initiate the reload, it will not initiate anything else. It will just say, okay, the command, I have taken it into account, but here is your to-do list in order to be able to use it. As long as you didn't do that to-do list, you are not able to use it. On the opposite, when you enter the command line to reformat the SSD, this will trigger a reboot immediately. Why am I saying all this? It's because to say this one, the second one, is dependent on the first one, but we can still do this one first because it will not trigger the reboot automatically. Then do this one as a second step, and this one will trigger the reboot, but with this, we are having just one reboot to have the two commands properly passed. So all this was just to say that by starting with the second square here, we are having just one reboot instead of two. But if you reformat the SSD first, we reboot, then we configure the system routing template security groups and we reboot, it would work as well. I just wanted to make this note. So that's it. Now let's check out the prerequisites from a hardware and software perspective. So this feature was introduced, as I was mentioning in the previous video, in the train 10.4. So if you want to see the documentation on that, it is actually inside the Nexus 9K series NXOS VXLAN configuration guide for the train 10.4. And you see here that we have GPO. So added support for group policy option on Cisco Nexus 9K switches, and it was on 10.4.3. The F at the end just means that it is a feature release. So from there, you can go to the detailed configuration guide, and actually the slides that I'm using into this video, I built them just doing some copy paste from these release notes because it explains the prerequisites, the different steps, the quote-unquote caveats, I would say as well. So that's it. Everything is in there. So I shared the screens just to show you how you can get there and retrieve more details than what I will be sharing here if needed. Now, we have also a limitation from a hardware perspective. To enable the feature, we need to have at least an FX3 or more recent, meaning a GX or a GX2. Knowing that 10.5.1 brings also the support in the Nexus 9408. So key takeaway from this slide, if you want to test the feature, you need to be at minimum at 10.4.3 into your environment, and you need to have quite recent hardware. As new releases will be created, new hardware will be introduced from a support perspective. And so it means that new generation will be supported, but probably as well a bit older generations as well. I guess this is how usually it goes, but it's always important to refer to the release notes. This is the only source of truth. In our lab, the two leaves are actually 9300 FX3 devices. And we are into 10.4.3 release. Okay, so this was the hardware and software prerequisites. Then we are going to see what I was mentioning from the perspective of the two first steps, which is the carving and the repartitioning. So the SSD repartitioning. So in order to be able to activate the feature that is needed to have all the security groups and the micro-segmentation configured, as we have seen previously, we need to change the routing template from the default one to this new one that is available only on this release that I was mentioning, which is the system routing template security groups. So this command will carve the tile profile required for programming host and subnet with security group tag, and tiles required for the SG-ACL reprogramming. This require a reboot. Then we see that this routing templates require an extended SSD repartitioning. By the way, the details on how the SSD repartitioning is done, we can find it into the series for NXOS fundamental configuration guide. So it's another guide. It's a fundamental for NXOS. And here you have the details for SSD repartitioning, but it is actually quite straightforward. It's saving the configuration. Also, it asks you, it makes a warning telling you that attempts will be made to preserve drive contents during the resize operation, but risk of data loss does exist. So back up your boot flash, your log flash, and your running configuration prior to proceeding. But apart from this, once you have entered the command and it tells you the warning, it asks you if you want to continue, and it will automatically trigger the reload in order to make the repartitioning. So again, long story short, it is two commands. You copy your running config in the startup config. You you save everything that you need to save just in case, and you run this command system flash SDA resize extended. So this configuration takes effect after a system reload, and the release notes also mentioned that the additional CFG and log flash storage space will come at the expense of boot flash, which will decrease in size. Once we have done this into our device, the subsequent disabling and re-enabling of the feature security group can be done without requiring a switch reload, fortunately. So this is just done once for all. Once we have done our system routing template security groups and we have reformatted our SSD, our leaf is ready to have the feature security group being configured. And if you want, we can just do a no of the feature when we want. So we can enable it and disable it without needing to do any additional reboot. So this slide allows me to summarize what I was speaking about. And actually I have recorded this, so I will integrate it into the video. We do the system routing template security group. We copy our running into the startup. We do the resize, so the repartitioning of the SSD. And then we are able to enable our feature security groups. And this last command is just a show command that we will be doing together in order to see that indeed we have learned that the other peers of the fabric are able to support GPO or not. Actually, I thought I had removed this command from the slide because I copied past it into the show commands, but never mind, it's there, so let's speak about it. Okay, so actually regarding the repartitioning and the enabling of the system routing template security groups, I have already recorded it because obviously I needed it in order to have my leaves ready for my testing before doing the recording itself. So it's already done. But when I did it, I recorded it at that time. So I am going to comment over the recording of that part. And then we come back to the quote-unquote live demo together. So let's go to the voice-over past recording. Let's start by doing a show system routing on the leaf 1 so that we can see what is the default template for the routing mode. So we see that by default we have the max host that is configured and applied on the system. Then in configuration mode, we do a system routing with an interrogation key mark so that we can see what are the different templates that are available for us. Now, again, the one that we need to be able to enable the microsegmentation is the template security groups. So we go ahead and choose this one, then we hit enter. We have the device presenting us our to-do list and some information. It says that indeed this is the template that we need to enable the feature security group, but it also mentions that this routing template requires the extended SSD repartitioning and that we will be able to exploit this template only after the next reload. Now, as we mentioned into the presentation slides, in order to spare one reload, we are doing first the system routing template security groups, then we copy our running into our startup config, and finally, we enter the command in order to do the repartitioning of the SSD, knowing that this command, so system flash SDA resize extended, will trigger automatically the reboot of the Nexus as soon as we have said that yes, we indeed want to go ahead and make the reboot. So we enter the command. It tells us, okay, there is a small risk of losing the data, so it encourages us to back up the boot flash, log flash, and running config to an external server. Once we have done this, we can go ahead and say yes for the reboot. In parallel, I have opened a console session to my LIF1, because obviously my SSH will be disconnected when I reboot, right? So let's go ahead and go inside the tab for the console. Again, where we will be able to monitor the thing. So here I'm doing just a fast forward so that we arrive at the moment when the system will tell us that it is starting the SSD repartitioning actually. So here it is doing various tasks of boot up and preparation. And here we are. Now we reach the step of the SSD resizing, so repartitioning. Now I will go ahead one more time to do a fast forward so that the video doesn't get longer than it is already, right? So here we see that the LIF1 has finally boot up. I'm waiting for the system ready. I see already that it tells me it has applied the template security group. And if we check with the show system mode for the, the show system routing mode for the template, we see that the security groups is configured and applied. So now that we have done the reformatting of the SSD for both LIF1 and LIF2, as well as the configuration of the proper routing template, we can go ahead and enable the feature security groups on both our LIFs. And just again, one small disclaimer, what I will do for the testing with you in this video is that I will first enable it only on LIF1, not yet on LIF2. But again, it's just for purpose of illustration. This is not something that is supposed to be supported. This is not a working environment, a working production environment. If you remember into our previous video on the theory for microsegmentation, we stressed that we can have a mix of Nexus 9K configured for GPU and other ones that are not configured for GPU or are in an older release or whatever, but just don't do GPU, as long as these two categories of devices are spread into multiple sites from the perspective of the Cisco implementation of multi-site, meaning using border gateways. If we are in a multi-site, we can have one site or multiple sites with GPU enabled and configured, as well as one or multiple sites without GPU configured, but they need to be in separate sites. Here we have just one site, right? A very small fabric. I will start by doing the configuration on LIF1, not yet on LIF2, just to do some show command and illustrations. Then we will do the proper configuration on LIF2 to be into a supported, working scenario, right? So with that said, let's go back to our devices. Here it is. Okay, I am on LIF1. And let me do feature security group. So again, for the moment, I have enabled it only on LIF1, meaning now I have feature security into my running configuration for LIF1, and for LIF2, I have nothing apart of my system routing template security group, obviously. So now on LIF1, we are ready to configure our security groups. So let's do it. And let's start with the security group named client. So the syntax, before doing the configuration, let's go to the slides to illustrate the syntax. So creating the security group is illustrated actually into the release notes that I was sharing previously, and I just did again copy paste from that. So we can specify any combination of the following attributes. We can match on IPv4 subnet or address or subnet for connected endpoints, as well as external subnets. Same for IPv6, and we can match a VLAN at a switch level. The syntax is security group. Then we give the security group ID. If you remember from the previous video, the range from 0 to 15 is reserved, but we can take anything from 16 to 65,535. This is why I picked 100 for the security group named client and 200 for the security group named servers. Then to match the endpoints or the subnets, it is match, then either connected endpoint to match what is connected to the leaves, or external subnets to match what we are learning through a routing protocol. Then we specify the VRF and the IP prefix. We can as well match on a VLAN or a list of VLAN. This one we will not be touching into this specific video because it is for redirection. And I think this is the last one as well. So we'll be exploring this into a further video. To be honest, as of today, I didn't explore the service chaining using security groups, but I will definitely do because it really looks like exciting. Very small notes regarding the match. Something that we will be illustrating into our testing is the importance of connected endpoints. I stressed this already into the previous video, but it is really, really important, so I will repeat it. When we have a match connected endpoint, it is really an assignment of a tag from the HMM process, meaning it is when we learn the IP to MAC correspondence from the ARP traffic that is being generated by a connected host, and we install it into the L2 RIB for our specific MAC VRF, that we are going to assign the tag. It means that leaf1 will be able to assign the tag 100 to the host 1, and leaf2 will be able to assign the tag 200 to host 2. Even if host 2 is connected to the fabric, leaf1 cannot assign that tag to host 2 because from when we speak about connected endpoints, it is really from the perspective of the specific leaf on which the endpoint is connected. When it comes to the external subnets, it is any routing protocol and any kind of redistribution, meaning if we take a leaf that is a border leaf and we do any kind of interconnection with an external router, if we configure, for example, a static route and we redistribute it into BGP, then for that route, we can, for the subnet of that route, we can assign a tag. Same thing if it is a direct learning from BGP, for example, on a point-to-point connection through VRF Lite, we can also assign to the subnet that we will be learning from this router a specific tag. Okay, so I think that's it. Now we can go back to our fabric in order to configure together the security group on leaf1. So the syntax is security group, then the tag, then we give the name, and it is clients. I will do my matching. As you can see, we have different things on which we can match. I will go ahead with connected endpoints. Then the VRF, which is blue VRF, and the IPv4 of the host, which is 192.168, trying to not make a typo, /32. So now my security group is configured. What I can do now is do a show IP route HMM into my VRF with the detail command. Was it that one? No, show IP route HMM as detail is here. Detail is here, okay. For my VRF, blue VRF. What is nice with this command is that we can show that we have the security group that is being assigned. So we can see it directly from the show IP route HMM detail for my VRF. There is multiple places actually where we can see it. We can also see it into the L2 RIB. So let's check it out for the MAC IP for our topology, sorry, our topology 10. So we see that now the host 1 has been learned, and we have assigned to it the security group tag 100. And something also that we mentioned into the previous video, but is really important to have in mind, if you recall, we have seen that even for bridge traffic, the lookup will be done on the IP address. It is because the tag is assigned matching an IP address. We are not matching a MAC address. As we have seen, there is no entry for matching a MAC address. It's just IP address. And it is very important because it means we need to have a routed fabric. We need to have an SVI configured on our leaves in order to learn the IP to MAC correspondence and in order to do the proper updates. And by the way, if we check the the update for the route type 2 update from leaf1 look like for this specific endpoint. We will be able also to see the tag that is being assigned. So let's do show BGP L2VPN EVPN, and let's look it up actually for the MAC address, so that it will allow me to really illustrate the importance of what I was saying previously. So if we see what are the updates that are generated by leaf1, as you know, when we are into working Fabric, we always generate two updates. I mean, a working routed Fabric. We always generate two updates for any attached host. There is one update, one route type 2 update to signal the NLRI for the MAC reachability, and another one with the MAC to IP correspondence. So we have always two updates. And as you can see here, we indeed have our two updates, the one that contain only the MAC, which has nothing from the perspective of the IP address, and the other one with the MAC to IP correspondence. And if you notice here, we have the PC tag, which is actually another naming to say the security group tag that is assigned to that endpoint, which is 100, that is being positioned for this update. But if you notice for the first update, which is just the MAC entry, we do not have any PC tag being assigned. So you realize that the importance of understanding how the pieces of the puzzle fits together. If we had just a layer 2 fabric with no SVI, we would not learn the MAC IP correspondence. We would generate just the updates for the MAC, and we would not have the PC tag assigned. So we need to have the routed fabric, and the PC tag is only assigned to this update. So we have checked the IP route where we can see, the routing table for the VRF, blue VRF, where we can see the tag. We have seen it also into the MAC VRF for the table corresponding to the MAC IP, not the MAC, but the MAC to IP correspondence. And we have seen it into our update for L2VPN EVPN. Let me quickly check my to-do list for the test to see what is the next thing that I wanted to illustrate. Okay, so a few points regarding the fact that leaf1 and leaf2 will either recognize or not, will recognize that the other one supports or do not support GPO. Let me just quickly clear the screen and illustrate what I have in mind. So at the moment, we have a very short configuration for the micro segmentation on leaf1, and the short command the helpful command if you want to check what you have is show run then security group. As you can see, we have just the feature security group, and we created our security group client where we are matching on host 1. That's it. And for leaf2, we do not have anything actually. Yeah, we don't have even the show run security group because the feature is not enabled. So that's completely not what we are speaking about. We don't have the show run security group because if you remember, we didn't enable the feature yet on leaf2, which is not something that we should do in production environment because it is not supported. So coming back to leaf1, I would like to do the command to see the details for the NVE peers. So we see from leaf1 that it knows that leaf2 is a peer from the perspective of VXLAN, and we see group policy capable, it is no. Now, you see incoming, we are going to take this command and put it on leaf2 as well. And here we see that it sees leaf1 as a peer, and it sees that leaf1 is group policy capable. Now, how do these leafs know who is policy capable or not? Actually, it is something that they derive from the announcements of the BGP updates from a specific leaf. When leaf1 was enabled with a security group for the feature security group, and we created our first security group in which we matched on host 1, we generated an update with the host 1 information, and inside the NLRI for the MAC to IP correspondence, we added the tag 100. When leaf2 has received this update, it has seen that we have a tag inside that update, and there is an internal process that allowed him to update the capability for its peer, just to mention that the peer indeed supports GPU. On the opposite, from leaf1, we didn't receive any update from leaf2 that contained a PC tag. Hence, leaf 1 is deducing that leaf 2 is at the moment not supporting GPO. So let's see the view of leaf 2 for the advertisements that we are announcing from leaf 1. By the way, I don't remember the MAC address. So let me find it again from our tab. So it is this one on leaf 2. So it receives the update from leaf 1. Let me look for the the advertisement that is of interest for here. So this one is imported, sorry. I want to see just the one from the global. No. Okay, it's actually this one. This one corresponds to the route distinguisher of leaf 1. So it's the one from the adjacency rib. So we can see that we received the two updates that leaf 1 sent us. The one for the MAC, it doesn't contain anything, but the one for the correspondence MAC to IP, we see that we have the PC tag. So this is what allowed leaf 2 to deduce that leaf 1 actually has the capability to support GPO. Now, again, at the moment, the configuration on leaf 1 is really straightforward because we configured only the match for our directly connected endpoint. And now I'm going to add a second line of configuration to match on the host 2, just to illustrate that despite we are going to configure the appropriate thing on leaf 1 to match host 2, leaf 1 will not be able to assign the tag. This is what we have been stressed into the slides previously, to really have in mind that connected endpoints is really connected to the leaf on which we are. So let me go ahead and do the configuration. So it is security group, the tag, the name, which is servers. And now let me try to not do a typo, match connected endpoints into our VRF, blue VRF. We are matching on IPv4 address, and the IP address of leaf 2 is 192.168.10.2, and it is a /32. Now let's check out the update. We are not even, it's not even us who is generating the update. It's not leaf 1, but let's check out the IP route. So the .1, it has the tag, and the .2, it has nothing. Actually, the .2 has a tag. It's the value of 15. It's actually a spoiler of what I wanted to touch at the end of the video, because for what we have a bit touched previously is we have a range of tags that we cannot take to do the configuration. It is from 0 to 15, and actually when we receive traffic from a leaf that is not configured for GPO, it means that nothing is set up into the VXLAN header, no gbit, no group policy ID for the source tag for the traffic that is entering. Then we put by default a security group tag of 15. But actually, what we want for host 2 is to be assigned the security group tag of 200, right? We see here clearly that we do not have a security group tag of 200. We have the value of 15. So, okay, let me do a quick drawing on this. It was not on the plan to touch it at this stage, at this step of the video, but never mind. Let me open a kind of whiteboard. Okay, so this is what we have at the moment. We have our leaf 1 here, and the leaf 2 here, and the spine. With our two hosts. We did the configuration on leaf 1 to enable the feature security group. And here we do not have this feature security group, meaning we are just implementing the classic VXLAN, which is the VXLAN of the RFC 7348. It means that now when host 2 is generating generating traffic for host 1 across the fabric. One leaf 2 will take that traffic and encapsulate it into a VXLAN header. The G bit of the VXLAN header will be set to 0. And the group policy ID, which includes, which is supposed to include the source tag for host 2 in the implementation of VXLAN GPO, this is all set to 0 as per the RFC 7348. When leaf 1 receives that frame with the G bit set to 0, since leaf 1 supports the feature security group and has the proper configuration, what it will do is take the internal host that is inside the packet and assign it a tag by default that is the tag 15. This is why into our show of the IP route, when we see the IP route for H2, we see that it has a tag by a tag to 15. This has been assigned by leaf 1. And I guess you will have the same questioning that I had when I saw this the first time. Can we configure some rules with the security group tag of 15? Yes, we can. So we can configure a rule calling that security group tag. This is what actually allows us to enforce policy between a device that supports GPU and a device that do not support GPU. Now, again, when we do this, we are supposedly inside a multi-site scenario, but we are still able to illustrate it into our lab environment, and this is why I'm creating this kind of discrepancy between leaf 1 and leaf 2 is still interesting to see. Okay, so this is where we are now. Let's come back to our lab and see again where we are so that we do not lose track of our commands. We have our two security group, client and server. We have matched everything. So at the moment, the host 1 is being assigned a security group tag of 100, and the host 2 is being assigned the default security group tag of 15, which corresponds again of traffic when we receive it from a non-GPU enabled VXLAN device. Let's say it like this. Okay, so let me quickly have a look again to our to-do list. Okay, so it's time for us to go to the next step of our configuration, which is configuring a security class map. So what is it? It is a class map that has a specific type, which is security. So when we enter into class map and we have the type, this time it is security. It is a new kind of class map. And it allows us to classify the network traffic based on various match criteria configured within the class map. So in order to configure the security class map, it is pretty straightforward configuration. It will allow us to define the filters. So on which protocols are we matching? Now, this might be a bit strange the first time we see it, because for the configuration of the class map as well as the policy map, we will not be calling the security group. For the moment, it's like a configuration of filters, like what kind of traffic are we wanting to match? Is it an SSH? Is it a telnet? Is it an ICMP? Whatever. Here, this is what we are defining. Through the class map, we define the protocols, the kind of traffic really, independently of who is generating it, what is the target of the traffic. We are just matching on the protocols. And in the policy map, we will be just calling the class maps on which we want to do the match with the appropriate action. It's only when we go at the VRF level that we will be calling the policy, that specific policy map on the specific security groups that we created, and this will, in the end, create our policy or our contract between our security groups. So again, this is why at this step, you do not see any reference to security groups. It is just matching on protocols to say what is the kind of traffic that we want to catch and to have some actions on. So let's go back. Actually, let's go back a bit earlier into our slide to see what we want to do. As I was mentioning previously, the goal of this recording is that we allow ICMP between the clients and the servers. So whoever initiates the pings, I want it to work. And we permit the SSH from the clients to servers. So the SSH into this direction needs to be permitted. Any other traffic must be denied. For example, we will be testing a telnet from host 1 to host 2. It will be denied. And if we initiate an SSH from host 2 to host 1, as well, it should be dropped if our configuration is done properly. Okay, so just let me go back to my slides and then let's go to the lab environment. Okay, and then now let's configure our first class map. I will do 2 class maps, but we can do it into one, of course. So it is a class map of type security, match any, and I will do an ICMP CL to SRV. So it will be match and IP and then ICMP. And then I will do another one of type security. And I'm matching the SSH client to server. And here I match on the TCP port, TCP, oh, D port 22. Okay. And let's call back our friend, the Shoran security group. This is what we had at the moment, our security groups and the 2 class maps that we have configured on which we are matching the appropriate traffic. So again, the class map, this is all what it does. It just allows us to define what are the filters on what is the kind of traffic that we want to match. Now let's go back to the slides where we are going to see the next step, which is creating the security policy map. So here it states what happens to the traffic that is classified using the class maps and the ACLs. So again, the configuration is, you know, when we are used to configuring class map and policy map, it's really the same philosophy. It's just that we are precising that the type is of type security, but we have been doing this for COS, for system QoS, for queuing, for many things into the life of network environment. This is just a new type of class maps and policy map, but the logic is exactly the same. So we call the class maps or the class map or class maps, and we do what we want to, if we want to, we do the kind of action that we have in mind. So is it a permit, a deny, or a log? And the second one, for now, I haven't tested it yet. It is the service chaining, which is for traffic steering between specific devices. I really hope that I will be able to make a video series on that. For the moment, what we will be doing is giving the specific type of traffic that we want to permit. Okay, so let's head to our lab environment again. I'm having so much fun switching between the tabs. So policy map, type security. Let me name it CL2 SRV. And then match the first one. Is this one. And the second one, which is this one. Okay. So actually by default it's a permit when we match it, but just for the sake of clarity, let me still go inside and configure it explicitly, you know. Okay. Okay, so even the showrun that show it because it's by default. Never mind, at least we did it. So we are confident that we are doing a permit into our policy map. So now we are ready to apply the contract between our client and our server finally. So let's go back to the presentation to show the syntax. The way we enable it is that we go into the VRF of that we are working on. I mean, for our case, it's the blue VRF. And then we do the security enforce tag. Sorry, I had in mind that I was reading the second line. So let me start first with the second line, actually. This is where we are applying the contract. So we give the keyword security contract, then we position the source, we give the tag for the source contract, for the source security group, sorry, in our case it is 100, and the destination, in our case it is 200, and then we call the policy map that we have just created. There are many important points on this slide, so let's take the time to review them carefully. As you can see, we can match on any for the source and for the destination to do some kind of wildcards if we need, so we have this flexibility. Also, important point, by default, the contracts are bidirectional. What it means is that when we have opened the flow from host 1 to host 2 for SSH, it will not only allow this flow, but it will also allow the return flow. So it means that we explicitly authorize the port 22 for TCP to host 2, but it means as well that the when host 2 initiates when host 2 initiates traffic from the port, so source port from the port 22, it will be allowed to host 1. So we do not need to have the burden of creating one contract in one direction and another contract into the other direction. If for whatever use case or for whatever reason we would need to do this, we can do it by using unidirectional contracts. But by default, we have bidirectional contracts. So if we do not specify anything at the end of the command line, all the contracts will be bidirectionals. Then if we come back to the first line, which is security enforce tag, the tag ID default permit or deny, this we have spent a lot of time on it into the previous video, and it is actually a very, very important line into the configuration to set up the mode of the VRF. It says if we are enforcing or not the configuration. Now, as a quick reminder, if we are not enforcing, it means that if we configure our security groups, our contracts, our class maps, policy maps, if we do the whole configuration, as long as we are not enforcing anything, the only thing that happens is that the tag is added to the end host. But this is all. The contracts will be completely ignored. We will not be able to see if they are matched. Even if there is flow that crosses the fabric and corresponds to a specific contract, we will not see the contract being hit because, again, we are not enforcing the microsegmentation. If we want to see the contracts being hit, in that case, we need to configure the enforce mode. So in our use case, we will at the end test the enforce mode. And here we are saying, what do we want to do by default? Do we want to have a permit or deny? Again, as a quick refresher, if we do a permit, it means that we are in a use case where all the security groups can talk freely with each other as long as we did not deny specific traffic explicitly. On the opposite, in the deny mode, it means that the security groups cannot speak with each other. And if you want to allow the security groups to speak with each other, we need to configure explicitly the contracts between them. Okay, so I think that was it for this slide. And yeah, the statistics can be showed by some show commands so that we see what is being hit or not. So with that said, I believe we can go back to our lab environment to finally apply our contracts between our clients and servers. So let's do that. Okay, so I'm back to the lab. I just did a quick clean of the screen. Now let's do our configuration. So we enter into the VRF context and we configure the contract. So the source is 100, the destination is 200, and the policy, oh, wonderful, it gives me the auto-completion. Thanks, NXOS, I love you. So, okay, we have configured the contract. Now let's say the default mode that we want. So we are going to enforce with a default tag of 300, and let's position a default deny for the moment. So this is the configuration that we have at the moment. We did the security group, the class map, the policy map, and inside the VRF, we are into enforce mode, and we have a default deny. So default deny again, it means that we need to explicitly allow the traffic that we want. So here we are allowing the source 100 to speak with the destination 200 with that specific policy, the policy being matching ICMP and matching an SSH traffic towards the servers. So this is what we are saying. Now let's start the funny part of testing our traffic flow. So at the moment, we have created a contract to allow 100 to speak with 200 with some on some protocols and some ports. And at the moment, we have our host 1 that is being assigned the tag 100, but actually the host 2, for the moment, we have completely left it alone, poor host 2, because if just I take back the slides to refresh where we are, we have not configured anything yet on leaf 2. So it means that here, the host 2, it still do not have its tag 200, so it doesn't have it yet. And what we have seen is that on leaf 1, since leaf 2 is not configured for GPO yet, we are assigning a tag 15 to that host 2. So at the moment, from the perspective of leaf 1, host 1 is being assigned the tag 100 and host 2 is being assigned the tag 15. And the policy that we have just created, what it allows is communication from 100 to 200, not from 100 to 15. And we are into enforced deny. It means that anything that is not explicitly allowed is denied. So I'm sure that you guess what happens now if we initiate just a simple ping between host 1 and host 2. Since it is not officially allowed, because host 1 and host 2, it is 100 and 200, the traffic is allowed from 100 and 200, while what we have now is 115, it will be dropped. So let's just confirm it so we are clear on it. Well, let me go to the lab environment and clear the screen. Okay, and let me do a copy paste of the pings that I have put into a notepad instead of my PowerPoint, on which I cannot do a copy when I am in presenter mode. So now what I'm doing is pinging the host 2 from host 1 basically, and I see that nothing is flowing. It is actually being denied. Now, for the fun of it, let's do a quick ELAM on leaf 1 to see what has denied our flow. Now, as you know, ELAM is is a utility actually that allows us to match on one packet of a specific criteria. So we define the criteria on which we want to match. And as soon as the switch has seen one packet that corresponds to our matching rules, it will catch it and we will be able to display it using the report. And what is very interesting with this tool is that it allows us to see what is the process that did a deny if we in the eventuality where we had a drop, which it's obviously the case now. So let's go to the leaf 1, and from here let me copy paste the text that I have already prepared for ELAM, so on which we will be basically matching on exactly the source and destination for our ICMP traffic, so from host 1 to host 2. Now let me start so that I am able to monitor the traffic, and let me regenerate a ping from host 1 to host 2. So now the report should give me something, hopefully. Okay, so we see that it has catched something. It says that we have the IP address 10.2 as a destination and the source is 10.1. And what we see here is we have drop info with the final drops information, which is the security group deny. So again, we are denying here because we are not matching any of our contracts. So we fall into the default deny of our VRF because it is being enforced. Now, the last funny thing that I want to make before going to our poor leaf 2 that is waiting for us in order to make the configuration there is I want to add a security group in order to allow the traffic towards the tag 15. So let's do this very quickly. So I will just do that, VRF copy. destination 15 with our policy. Okay, now let's do again our ping, and the ping is working. So it is working because we have allowed it through that policy with the destination of 15. So what is nice with the 15 is that we can still do include it into contracts, whether it be the source or the destination, we can do it. Okay, so let me just, to be this on the safe side, verify that there is no other test that I want to do before configuring the Leaf2. Okay, oh yeah, I noted to remove the line. Well, okay, let's remove it. And we should have again the ping being dropped. Good, so now let's go to our Leaf2, which has been waiting for a long time, and let's do basically, sorry, let's do a copy paste of the configuration that we have on Leaf1. Again, our front shore and security group. Let me put it here, copy paste, that's it. So now we should finally have our host 2 being added to the security group servers. So it should have the security tag 200 finally. So let's check this out. First through HMM, VRF. Oh, I forgot detail. Because if we don't put the detail keyword, we are not able to see the security tag, and we see it. Hopefully we have it. And now if we do a check of the L2 route, so the MAC VRF. So L2 route for the MAC IP correspondence for the topology 10. We see that we have the correspondence, here we see the correspondence MAC IP, and we see that we have our tag 200. And host 1 obviously it still has its tag 100. So here we are finally into a happy world where our host 1 is positioned into the security group clients, and the host 2 is positioned into the security group servers. And since we have configured the proper contracts between the two, now we should be able to see what is being allowed and what is being dropped through the test that we can initiate now. So let's go to the hosts and first do a ping, which should still be working. So the ping is working. Let me do a copy paste of the SSH from host 1 to host 2. So again, 4.10, it is host 1 because it's connected to Leaf1, and we are SSHing to host 2. So we are allowed to SSH. Let me go out of the SSH. Now let's try to telnet from host 1 to host 2. And this is actually being dropped. So eventually we can play again with the ELAM just to see that the traffic is being dropped. So let me go back to Leaf1 and take again my ELAM configuration. Let me maybe just clean the screen. Not clean crypto. Okay, good. And regenerate actually a telnet. So here we see that we have matched our flow from 100 to 200 on the destination port 23, which obviously is telnet, right? And we are dropping it because of the security group being denied. So again, we can see that the security group is being applied. And again, checking. Oh yeah, let me now do the same command that we did in the beginning, show NVE peer detail. So here we can see that Leaf2, from the perspective of Leaf1, we see that it knows that Leaf2 supports the group policy capability, so the GPO. And let's see also an interesting show command, which is show contracts, the name of the contract, right? No, show contract, policy, and the name of the policy. Oh, fortunately, there is not the auto-completion. Client, no. So my policy is client to server. And this command is interesting because we see that the contracts are bidirectional into the output. So again, it illustrates that we do not need to open the two directions when we have a specific port. So the return flow will be automatically allowed thanks to this contract, sorry. Okay. There is a very last thing that I wanted to illustrate, which is checking the header of the VXLAN so that we see it clearly into the capture. So let me quickly do the proper setup in order to capture it. So maybe what we can do is, either on leaf 1 or on leaf 2, we will be capturing the traffic that comes from the spine and see the details of the encapsulation. Or let me do it on leaf 2. Oh, sorry. So let me see what is the interface towards the spine. So it is 1.4. So let's configure a monitor session 1. We don't shut it because I always forget to unshut. The destination will be the SUP. So actually what I will be doing is a mirroring to the CPU so that I'm able to use Ethanalyzer. So as you probably know, Ethanalyzer is a nice tool as well, like ELAMP, but what it will capture is actually the traffic to and from the SUP. And since here I'm capturing in the data plane, it's not, I'm just capturing traffic from host 1 to host 2, or the other direction, but whatever. It is traffic into the data plane between 2 end hosts. So it's not traffic that is redirected to the SUP of leaf 2. This is why I need to configure a mirroring so that I redirect any traffic to and from the spine towards the SUP so that I'm able to monitoring using Ethanalyzer. So the destination is the interface SUP Ethernet 0, and the source interface would be the one to the spine. So 1/4, which is this one, in both directions. So now that the monitor is configured, we can go ahead and launch the Ethanalyzer. So in band, and I'm mirroring, and then I'm doing just a very easy capture filter. Actually, I will be matching on the UDP destination port for VXLAN, which is 4789. And I'm adding the limit capture frame to 0 so that we are not limited by the 10 frames. Otherwise, we would stop at 10. And a detail so that we see the detail of the encapsulation. Good, so we launch it, and then we go back to our hosts, and then we launch a ping. So leaf 2 has captured something. Okay, let me stop it here. Okay, I should have locked the session to copy paste to open it easily into a text editor, but never mind. Here we should be able to find what we are looking for. So this is the outer MAC header. We don't care about it. The outer IP header, we don't care about it. We see that it's actually traffic from leaf 1 to leaf 2 for the external encapsulation. And here is the interesting part, the UDP and the VXLAN header. We spent quite some time into the previous video speaking about the different fields that were reserved into the original RFC, meaning the RFC not 4789, this is the port, 7348. for the VXLAN. So we have seen that in classic VXLAN implementation, the R bits should be set to 0 at emission and should be ignored at receipt. Some of those bits have been taken by the community of engineers in order to enable the capability for group policy option. And these bits are actually illustrated here. This is why I wanted to show the capture. So the very important bits that we spoke about extensively into the previous video was the G bit. So it is actually the first bit of the flag part into the VXLAN header. When it is set to 1, it means that we are supporting and implementing GPO. And when it is set to 1, it means that we necessarily need to carry inside the header into another part of the originally reserved bits, the group policy ID for the source of the traffic. Now here I am on leaf 2, so let me quickly show where actually we are. So we are initiating traffic from host 1 towards host 2, and we are capturing here. So the packet that we are currently displaying is the first packet, so actually the ICMP echo. So this is why the host 1 is the source and the host 2 is the destination. And what we can see is that the tag being, the policy ID or the security group tag being carried is the 100, which is obviously the one of host 1. So it's normal that we are seeing this. So if we go back to our lab, so again, we have the G set to 1 and the group policy ID set to 100. The other bit that is important that we saw in the last video is the policy applied bit, which is at true. It means that leaf 1 has already applied the policy. So leaf 1 has allowed the traffic, hence it flipped the bit to flip the A bit to position it to 1, so that when leaf 2 receives the encapsulated frame, it knows that the policy has already been applied, so it doesn't need to check again the contracts. Now I want to mention a very last thing regarding the header, which is the don't learn bit. I was mentioning also in the previous video that I'm not fully clear on the importance of this bit, since in VXLAN L2VPN EVPN, I mean with VXLAN with the control plane, we should not learn from the data plane anyway. So I'm still trying to figure out the importance of this bit. What is its added value, let's say. So this is why I'm not spending more time on it. But really the main fields, it's not the don't learn bit. It is the G bit, it is the policy applied, and it is the group policy ID that is being carried into the header. All the rest of the fields, whether it be for the VXLAN of the VXLAN header itself or the UDP or IP for the encapsulation, it is exactly the same as the original RFC. Good, so I believe that's very it. There is a last point that I want to touch. It is actually in the configuration, something that I have not yet spent time on, which is this tag that we see into the security enforce. We have not referred to it into the check and the show commands and so on. And same as for the dbit, I'm still looking at what this tag does for a living. So far, my understanding is that it is used internally in order to match specific kind of traffics like multicast and broadcast. So to allow the BUM, because as we have seen and we discussed previously, all the micro segmentation, it actually applies to unicast traffic. So switch traffic, routed traffic, but unicast. The BUM and so the multicast and the broadcast is naturally permitted by default and implicitly configured rules that we don't need to set up manually. And my understanding is that tag that we are configuring into that line has something to do with this, but I'm still looking into it. So this time I believe it is pretty much it. I sincerely hope that the video has not been too difficult to follow because of my going back and forth between the different screens. I have the feeling that I will have a very nice time at the edition part. Please let me know your thoughts into the comments below. Anyway, thanks a lot for having watched, and hopefully I will see you in next video. Please take care.